Hello, good morning all.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning. So I hope you have watched the analysis for our previous experiment. Have you?
Yes, sir.
Yes, sir.
All right, good. Clear?
Yes, sir.
All right, good. So today we're going to
Sir,
see. Okay.
I have a question about the last, like the first practical.
The, you have a question on what?
Like how to present our results. Like for the table, are
Yes.
we meant to be are we meant to change everything to two significant figures as we go? Or we should just leave it till the last answer?
Okay. For each column,
Yes, sir.
maybe if you have chosen two decimal places for a particular column, then you have to finish with same significant figures and decimal places. So for each column,
Okay, sir.
if you have taken 2 for column 1, then you have to complete it with 2. If you have taken 3, then you have to finish it with 3. Do you understand?
Okay, sir. Thank you very much.
All right.
Yes, sir. Thank you.
All right. Good. So our experiment for today is, as far as I'm concerned, we're done with experiment 1. We've done the analysis. Okay, after the experiment, I've sent the analysis to you for you to watch and get back to me if you have any problem. So I'm happy that you don't have any problem so far. So we're going to move to our next experiment, which is experiment 2. The analysis is supposed to be on live. We're supposed to have it live, just as our normal lecture, but because we don't have time, and last week it was a break, so we can't afford to skip the whole week without doing anything. That's why I've sent the recorded version of the analysis to you. So this is our next experiment, and the title of the experiment is Determination of Young Modulus. Determination of Young Modulus. So we have to determine young modulus by means of cantilever experiment. We have so many methods used in determining finding the young modulus of a particular material. For example, we can use an ultrasonic method, which is also known as echoing method. We can also use a resonant method, and we can also use a bending method, also known as cantilever. So before we go into our experiment, I would like to know if you have any idea on what young modulus is all about. Young modulus. Do we have anybody that have an idea on what young modulus is?
Yes, sir.
Okay, so what can you say about it?
So young modulus is like the ratio of tensile stress to tensile strain.
Yes, tensile stress to tensile strength. Okay, so if you are to explain this to a layman, how is it going to be? Because a stress, we all know what stress is. But what about strain? Strain.
So when you have, if you're calculating, when you have your extension,
Yes.
you divide your extension by the original length of the object, which was the original length of the object. Yes, sir.
extension.
Yes, sir. Your extension all over original length gives you the strain.
Okay, okay, yes, that's what strain is, right?
Yes, sir.
The rate you're going to achieve by what? Stressing or we can say extending something or compressing it, right? Mostly elastic body, right?
Yes, sir.
Okay, so we have chosen a cantilever method. So I would like to know if you have any idea on what cantilever is. Cantilever. But if you are to explain your modulus to a layman, you can just say the measure of stiffness of something. Stiffness. How far something can be strained or how far you can be able to extend something to a certain length without breaking. Yes. So cantilever or pulse method, also known as echoing method, is so obvious from the word echoing. And also for resonant method also, it's also another simple method. But what about cantilever? If I say cantilever, what do you think? Bending method. Another simpler form or simpler name for cantilever is bending. So cantilever is anything that has been displaced horizontally with only one support at one end. For example, you're holding a meter rule, you're holding it horizontally. The only support you have is the part you're holding it, one each. The other edge is going to what? Have an extension, either depression or extension of what? But mostly what? A depression. So cantilever, we have it in so many mechanical stuff. We can say that yes, the most building are what are held by a cantilever method. For example, for you to make a very good roofing, you must have a support, and in most cases, the support comes from one end of the building. So the same thing, the most easiest and yes, easiest method to demonstrate is by holding something at one end. So I'm about to, as you can see from the image on the, yes, from the image of the experimental setup, we have a meter rule, 2 meter rules. One is being displaced horizontally and the other one is vertically. And if you look at the displaced one, the horizontally displaced meter rule, it has only one support at one end, which is our cantilever. And we have another one for measurement, which has been displaced by the meter rule standing, by the retort stand. So we're going to make the same setup and measure the young modulus of this particular meter rule. So the 2 meter rule we have are of different types, or we can say they are being paved with different color. One is white and the other one is, I think, we can call it red or yellow. So both are being paved. We all know that a meter rule is made from a wooden material. It's made by a wooden material. And we also know that we have so many types of wooden material which are of different young modulus or different strength. So the reason why these 2 meter rule are being paved with color is for you to be able to know the young modulus or to be able to identify the type of meter rule we have without knowing the internal color or future of that particular meter rule based on what? Mechanical experiment by young modulus. So by end of this experiment, you will be expected to identify the type of meter rule that was given to you only on the cantilever setup, not the standing one, but only the one horizontally displaced meter rule. So you should be able to know the type of meter rule that was displaced horizontally based on the young modulus value that you're going to achieve. And also based on that value, by getting that value, you have to compare it with the young modulus of so many different wooden material that you can find online. That's why we always make provision for referencing in your lab manual so that you will cite the, the book or the link that you have consulted in getting the young modulus of various metal or various wooden material that you can find online. So I am going to, we're going to make the setup together. I'm about to share it now. So these are the required apparatus for the experiment. As usual, we need a vernier, we need a micrometer screw gauge, which I believe you will know how to handle. And this is our cantilever meter rule. If you look at it, it's white in color, which means it has been paved with colors. So you have to be the one to wants to determine the type or group that this meter rule belongs to by comparison. So we have just measured the thickness of the meter rule, which is something that you need to record. All I have to do is to pause it and then we'll take the measurement together. So this is the thickness of the meter rule. So I would like you to take the measurement. What do you see? What do you see? Hello? Can you give us the upper barrel reading? Can anybody give
It's not clear.
the upper barrel?
So it's not so clear.
7.
But it's clear to me. But let me see.
So I can't see it.
Okay, let me see if it can be more clearer. Now it's clear.
7.
Okay, yes, somebody said
7.
yes, 7. We have our
7.
upper barrel value. Our upper barrel value is 7. Then what about our lower barrel? Can we see the line halfway from 5 to next value? Sorry, from 7 to next value.
Yes, sir.
Yes, sir.
Okay,
Yes,
so
sir.
since we can see it, then we can add 0.5 to it, right?
Yes, sir.
Okay, then can we go to our, can we go to our spindle value?
Twenty-one.
That's 21.
For the spindle, okay, 21, yes. You can take 21. You can take 21.5 if you want to, because it's between 21 and 20, right? Sorry, you can take 20.5.
20.5.
Yes, 20.5. So I believe you know how to take the summation, right? Of your barrel,
Yes, sir.
upper barrel, lower barrel, and the spindle value. So I'm expecting you to do that. I record it to your book. I'm not going to say it anymore. This is your own work. You have learned how to do it. So are we done? You
No, sir.
give your value You're going to need it when compiling your report.
Sorry, sir. I didn't get the lower barrel value.
The lower barrel,
Yes.
I think that was our first or second lecture. You will look at the line on the lower barrel. Let me go back. If you look at each of the line on the upper barrel, are you with me? Each of
Yes,
the
sir.
calibration on the upper barrel have line between itself and the next line to it. For example, if you look at 0, starting from 0, 0 and 1 have a line under between them, right? The line is
Yes.
halfway between 0 and 1. And also between 1 and 2, we have a line which is halfway, right?
Yes.
Okay, so if you can be able to see that line after taking the value for reading from the upper barrel, then you have to add 0.5 to it. But if you cannot see that line, then you have to ignore it and add 0 to it. But since we can see the line, if you look at it carefully, after 7, each calibration stands for just 1 millimeter, right?
Yes.
The upper barrel. So if you can count from the upper barrel, you can see that yes, we can view exactly 7 lines starting from 0, 1, 2, 3. We can view exactly 7 millimeter, right?
Yes.
So then for the lower barrel, then you have to look carefully to see if after that 7, your last calibration or value on the upper barrel, if you can be able to see the line in between that particular value to the next value, then we can assume that we have additional half. You understand?
Yes, sir.
But can you see the line between 7 and 8? We can't see it, but we can see 7. So under 7, can we see any line?
Yes.
Yes, we can see the line, which is halfway between what? 7 and 8. Right?
Yes, sir.
That's why we're adding 0.5. Do you
Okay.
understand?
Thank you,
And
sir.
then next thing to do is to move to our spindle value, which is the value perpendicular to your barrel line. Do you understand? And if you look at it, you also have what calibrations on it. So you're going to take your value based on the calibration and based on the line that, you're going to take the value that coincided with the line on the barrel. So now, if you look at it, we have 20. 20 is a bit, it's closer, but not really on same line with the barrel line. So we'll have to look at the value that precisely define, yes, or coincided with the line on the barrel, which is 20.5, or we can say 20 and a half. Sorry, not 20 and a half, not 20.5. 20 and a half, right?
Yes, sir.
Okay, please, I would like you to go back to your lecture 1 and watch, no, not exactly lecture 1, I can't remember, I think lecture 1 or 2, and watch, yes, watch the video on measurement carefully. Watch it and get back to this, because I would like to have a precise value on this. If you mistakenly add something or reduce something, definitely you're going to have problem. So please
Yes, come on.
watch the video.
From this. Okay, can any of you tell me what's the main scale?
What's the
5 by 0.3, become 5.8.
I can't
So
hear
that's
you.
how we take.
You said? Eh? What do you say? I'm listening. Hello, somebody was saying something. Who was that?
Sir, I think it's the
Okay,
background noise.
okay. All right, good. Okay, so we're going to proceed. Okay, so we need to know the required apparatus for that we needed for us to carry out this experiment. So before we start, I would like somebody to read line, the first line from yes of the method. Okay, Alex.
Yes, sir.
Okay, can you read the first line? You can stop
Okay.
exactly where the full stop is at.
Okay.
All right.
A fixed load of mass 150 grams to one free end of the meter rule.
Okay, so this is for what? The horizontal meter rule, right?
Yes, sir.
Yes, we're going to affix a load of 150 gram to it. Okay, and then to be sure that you're all around, Stephanie, can you continue
Yes, sir.
to the next comma, to the next punctuation mark? Yes.
Clamp the free end of the metal rule firmly to the edge of the bench by means of a G clamp or otherwise.
Okay. Okay, so based on these two lines that you just read, you see that yes, we will need what? A mass or load of 150 gram. So that should be part of your apparatus. You're supposed to record it as your apparatus. You have 150 gram, and then the second line, she says, we are to clamp we were to clamp the free end of the meter rule firmly to the edge of the bench by means of G clamp or otherwise. So we're going to need what? A G clamp again. So a G clamp also is going to be recorded as one of our apparatus also. We have two apparatus so far. Then Raymond,
Sir.
to the next punctuation mark, can you read? Raymond. Okay. Zainab Aliu.
Sir. Sir.
You're quiet. We don't have time to waste. Zainab Aliu.
With a definite length, 95 centimeter projecting from it.
Okay, that means we're going to, the length of the meter rule that we're going to use is 100 centimeter. Do you understand? But the length
Yes, sir.
that we're going to attach to one end of the length that we're going to attach to our G clamp is going to be at 95. That means we're going to what? We're going to remove at least 5 cm from what? The length of our meter rule by attaching it at 5 centimeter. That's what it means. So if you attach it at 5 centimeter, that means the part that is going to be displaced is going to be 95 cm. Do you understand?
Yes, sir.
All right.
Yes, sir.
Okay, so from there, Peter, what do we do next?
Note that their fixed load will cause only a small depression.
Yes. So by
Set
attaching
the
some,
meter rule with the
okay, we
set the
said,
meter rule with their fixed load into
okay,
vertical vibration
okay,
by exciting it through a small vertical displacement.
okay, stop.
Then we measure the periodic
Yes,
time.
stop. Oh, yes. So he says we're going to set it immediately after affixing one end of the meter rule to our bench horizontally. Definitely is going to what? Have a vertical vibration, or it's going to displace itself vertically. We're going to have a little bit of a vibration even before attaching our load to it. So anything that you're holding, if that body has some element of elasticity in it, definitely is going to swing if you're holding it at one end. So a meter rule is also what, an elastic body to some certain extent. You can bend it, but you can't compress it. You can definitely bend it. So if you can bend it, then by holding it at one end, it's going to do what? It's going to have a small depression downward. So then we're going to set the meter rule, or we're going to affix our load, which was initially stated to be 150 gram, to the other end, and allow it to have a vertical vibration for 20 oscillation. So this is to know whether the meter rule is going to be an elastic body after this vibration at 95 centimeter. So if after doing so, we have checked the elasticity and the meter rule still remain at same position, then it means our meter rule is still elastic 100% even at 95 centimeter. So we were going to we're going to take the next reading by eliminating another 5 cm. From 95, if you remove another 5, is going to be 90. The remaining path that is going to be displaced is going to be 90 cm. So I would like Dabai, can you read from where he stopped? Dabai, Aisha Dabai. Okay, Drusilla. Drusilla.
Yes, sir.
Okay, can you read from where he stopped?
Sorry, sir. Please, where did you stop?
Okay, he stopped at by exciting it through a small vertical displacement. Full
Okay.
stop. This is
Measure the
line 5.
measure the periodic time T
Okay.
for 20 oscillations. Measure
Yes.
the
Go on.
measure the width B and
B.
thickness D of the meter rule.
Okay, so you're going to need what? The thickness of the meter rule and the width of the meter rule. So we have already measured the thickness. The next thing to do is to what? To know the width.
Yes.
Yes. Okay, Nana boy, can you read the
Yes, sir.
remaining? Okay, continue from where she stopped.
Repeat the experiment by reducing the definite length L
Okay.
from 5 centimeters to a minimum length of 65 centimeters.
Okay, that means we're starting at 95 by eliminating 5. So after doing for 95, we're going to what? We keep removing 5 out of what? The length of the meter. We keep adding 5 to it. We started with 5, which left the remaining part, or the displaced part, to be 95. And then by reducing another 5 is going to be 10. And we're going to have 90 cm to displace. Then we'll keep removing 5 until we attain the length of 65 cm. So for each length, we'll have to allow it to swing for us to check whether the meter rule is going to remain as elastic or is going to have a bit of a depression. So we're going to find out, and then we'll be able to know the young modulus based on that. So since we've already recorded our Based on this, you should know that we need a retort stand, we need 2-meter rule, one standing and the horizontal one. And we also need a G clamp to make sure that our affixed, horizontally affixed meter rule is well attached. And then we're going to need our stopwatch for us to record time. And then what next do we need? Have to make sure that you have everything. Yes, we also need a micrometer screw gauge for us to take the measurement of the thickness and the width of our meter. So these are the required apparatus for this experiment. We can now move to our experiment page. Okay, so we have taken the measurement of the thickness, and now we're taking the measurement of the width of the meter. So what do we see? Can we take the value for the width? What do you see on your upper barrel?
26.
The upper barrel.
25.
26.
26.
26, sir.
Somebody is saying 26. But do
That's
you think,
26.
can you see the line on 26?
No, sir.
25. 25.5.
5.5.
Okay, so if you can't see the line, then you can't take it.
So it's 25.5.
Yes,
25.5.
definitely on the upper barrel, we can see 25, but you can't see 0.5. That's why the lower barrel is given for you to take the subsequent reading. So you can't just see 25.5. All you have to do is to be able to view all the calibrations on the upper barrel. So since you can view 25, then you can only take 25. You're only allowed to take 25. You can't take something that you can't see. The remaining values will come from the other part of the micrometer screw gauge. You shouldn't worry, you're going to end up with exactly what you need. Do you understand?
Yes, sir.
But excuse me, sir, I zoom in, I'm seeing 0.5.
Yes, I said it's 25 because you can only see 25. Can you
Yes,
see the next?
0.5. Yes, sir, I can see the
You
0.5.
can't see 0.5 because what I said is the value on the upper barrel alone. I'm not asking of the lower
Okay.
barrel. Remember, the whole measurement is going to be complete by taking the value from the upper barrel, lower barrel, and the spindle, right? So now we're dealing only with the upper barrel.
And
Are you with me?
dentistry, three examples.
Yes, sir.
So
And
what do we
dentistry. Now go to the posting.
Zainab Ali, can you mute your mic? You only unmute it when you're about to talk. Zainab Ali, are you with us?
Sir.
Okay.
Sorry.
All right, fine. What do we see on our upper barrel?
25.
25.
Good.
25, sir.
What do we have on our lower barrel?
0.5.
0.5.
You see, your half has come out already, right?
Yes, sir.
So the value of the upper barrel is just 25. You only record what you can see. And the reason why we are taking the 0.5 for the lower barrel is because we can see the line that represent halfway from 25 to the next value, right, on the upper barrel. So we have 0.5 there, and then we move to our spindle value. What do we see there? Which line do you think coincided with our barrel line?
15.
15. So that 15 is same thing as 0.015, I think. If I could remember, I believe you know how to sort it out, right?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
So
This
what
is your
the
own work.
unit?
The unit is millimeter.
Okay.
Yes, is in millimeter. Okay, so this is our the value of the thickness, sorry, the width of our meter rule. So the next thing to do is to make sure that we have the precise or the required load for the experiment. The required load for the experiment. Remember, this is how our table is going to look like. We already know that, yes, we're going to take a displaced length of 95, starting from 95, and then we'll stop at 65, which made our serial number to be 7, 1 to 7. Starting from 95 in space of 5, we're going to have 95, 90, 85, 80, 75, 70, and 65. So the next thing is to make a column for the time T1 and time T1 and time T2. So how do we take our time? So we have to make our setup before looking for a way to take our period or time. So now, the meter rule is going to be attached to length of 95 by displacing or by making sure that our G clamp, yes, so you have to make sure that that 95 coincided exactly with the age of the bench that you are attaching to. So what I'm about to do is to attach the meter rule to yes, I make sure that yes, the age of the meter rule, the bench that I'm attaching to, is exactly or is coincided with exactly 95 on the meter rule. View. Oh, sorry, sir. Please keep it down. You're distracting us. As you can see, we have a vertically displaced or yes, standing. We have one of our meter rule attached to our stand vertically, and we have the horizontal one, which is crossing the vertical one. But the vertical one is for measurement, for us to know the length where the horizontal meter rule is at before attaching our load. So we'll have to make sure that we know the length so that we'll be able to know whether the meter rule has depressed or not. So this is the standing one, and this is the vertical one. As you can see, they both have a different color, but our concern here is the white one. So now you have to take your measurement to see where the meter rule is at, and you have to make sure that your standing meter rule is constantly yes. After attaching it, you have to make sure that you didn't change anything throughout the experiment. If this is where the standing meter rule is, then you have to make sure that it remains where it is throughout the experiment for accuracy. Exactly where it is. So this is the initial and final position that the standing meter rule is going to remain at. As you can see, after attaching a load of 150 grams to it, it's depressed downward. But the question here is, after detaching it, is it going to move back to that initial length? We don't know. We have to allow it to swing for 20 oscillations before we check. So this is around 25.5. Yes. So before attaching the load, so this is what you're supposed to record first. Now without load, where do we have? At 95. Without load, it's exactly on 38. It's exactly on 38.2. I think either 38.1 or 0.2. But believe me, the accurate value or reading has been recorded already. So then you will attach your load and extend it back to that 38. So you have to measure the length before attaching the load. So after recording the length where the meter rule is at before attaching the load, then you have to record that value as your initial value without any load attached to it. Then after attaching the load, it definitely is going to be depressed. It will move downward. Then the next thing to do is to drag it back to that initial length and release it. Then you allow it to swing for 20 oscillation. After 20 oscillation, you remove your load and check whether the meter rule is going back to that initial length, which is 38. So if it goes back to that initial length, then your depression is 0. And also, yes, depression is 0, and extension also is going to be okay. Before extension, let's see. Now we're going to extend it back to that exactly. Exactly 38.2. So you'll extend it and then you release it and allow it to swing for 20 oscillation. So don't worry, it wasn't very clear, but it's going to be. This is for a test. We're about to start. This is our stopwatch. The digital one is more accurate. So now I'm going to extend it back to exactly 38.2, and then I'll allow it, I'll release it, and then start my stopwatch and allow it to swing for 20 oscillation. The moment I'm releasing it, I'll also start my stopwatch. the swinging might not be perfect, but all you have to do is to count number of time it goes down. So after 20 oscillation, you record your time T1. And then on that same length, which is 95, you will allow it to swing again. You take it back to that initial length again. This is 18.16. Oh, sorry, yes, 18 second, 0.16. So you take it back again to that initial length, which is the length without any load attached to it. And then you release it and allow it to swing for another 20 oscillation. Remember, the standing meter rule will remain in same length, no adjustment. So you only count the number of time it goes down. Remember, the swinging cannot be perfect. So just take the value or the number of time the load goes down. Once it's 20, you stop it and take the value. 18.36. Remember, your load must be attached with a very light string, probably or yes, preferably a thread. Don't use something that will add weight to your meter rule. Always use a thread. So now we move it back to 90. We are now deducting 10. We make sure that 90 coincided with the bench. So now you're going to see it is exactly at 90. You make sure 90 coincided with the bench. So the line on 90 coincided with the age of the bench. This is our second reading. Our second reading. I remember the standing meter rule is also movable such that you can move it forward and backward, but the length must remain where it is. Yeah, so you can move it forward and back. Yes, because your meter rule length will keep reducing. So therefore, you will keep adjusting the meter rule from the top, but not by length. So now we'll have to record the length, initial length again before attaching any load to it. So before attaching any load to it, remember the initial length has been recorded already. So it's going to be given. So this is our initial length for the second one. It's somewhere around 40.5. 40.5. But you shouldn't care because the accurate value has been recorded already. But this is somewhere around, this is 40.5. Then we're going to attach our load to it, and it's going to be depressed downward. So with our load attached to it, we can now take it back to that 40.something.5, and then we allow it to swing for 20, another 20 oscillation. The aim of this experiment is to stress our horizontal meter, to stress it with load. to see how much is going to sustain or how much is going to last without attaining permanent bending or permanent. This is 16.35. So as you can see, the more you are reducing the length, the lesser period you're getting. So as I've said, we're not going to do all of them. The aim is just for you to have a clue on how to go about it. And then the remaining columns will be filled. So as you can see, these are the values we've gotten for 85, for 80, for 75, 70, and for 65. It's the same procedure, so therefore we're not going to take the record. We're not going to record the entire experiment. All you have to do is to take at least 2 columns together with you, 2 rows together with you, for you to know how the values have been gotten, have been acquired. Okay.
So come back again, please. The table.
Okay, I'm coming. I'm going to explain more on the table. Okay. All right. Can you do the table?
Yes, sir.
Okay.
Yes,
so,
sir.
okay, so there are a few more things that I would like to explain on the table. This, if you look at the last column, we have S. S. Are you with me?
Yes, sir.
We have
Yes, sir.
S. Yes. So this S, it means the depression of the meter. If you can remember, by attaching load to it, you have to take it back to its initial length without load, right?
Yes, sir.
You take it back, then you allow it to swing for 20 oscillation. After 20 oscillation, you record your time T1, and you do the same thing and record time T2 before taking average value, right?
Yes, sir.
Okay, so this depression S, we found it from, yes, for example, after taking your initial value, remember, after doing, attaching the load, you will take it back and then allow it to swing. So after swinging it for 20 oscillation, you should expect your meter room to be depressed a bit, because after removing the load again, it may not go back to that initial length. Let's say, for example, our initial length before attaching any load to it at 90 centimeter, let's say is 38 on the vertical meter room. And then after attaching load, it goes downward, it depressed, and then we took it back to that initial length, which is 38, and then allow it to swing for 20 oscillation. So after that 20 oscillation, we recorded our time, and then we remove the load and see if it goes back to that 38. So if it goes back to that 38, your depression S is going to have a 0 value, which is 0 centimeter. But what if it goes back to 38.2? That means you have to subtract 38.2 from your initial 38, which is going to be 0.2, right?
Yes, sir.
Do you understand what I just said?
Yes,
Yes,
sir.
sir.
So that's how I got the value for S. That means on 95 centimeter, your meter rule is not 100% elastic. It has depressed after attaching load to it and allowing it to swing for 20 oscillation. The meter rule has become yes, a bit stiff or has lost some of what its elasticity by 0.5 or 0.1%. It's more like this. Do you understand? Or you can say by 0.1 centimeter, which is equivalent to that 0.1%. Do you get it?
Yes, sir.
If anybody has a problem on how we got our depression S, please should ask.
So I still don't understand.
All right. Let me go back to the experiment and explain it again. All right, are you with me?
Yes,
Yes,
sir.
sir.
Yes, this is our meter rule. Okay, so I'm going to explain it here on value of 90 or on length of 90 centimeter. So depression S when length is 90 centimeter. Remember, in taking this value or reading, you have to avoid perpendicular error. Error due to parallax, you have to be very careful with it. So now, we're going to assume this is where our meter rule is at. So now what can you see? Can you choose any value that you can see? Who can tell us where do you think the meter rule is exactly at? The horizontal one.
40.
42.
40.5.
40.5.
40.2.
I can see 40.5, right?
40.2.
Somebody is saying 40.2, but believe me, I have chosen the accurate value. So now I just want you to guess, then we can take our assumption based on your guess. So what do you think is at? Can we take 45? 40.5, sorry.
Yes, sir.
Yes, sir.
Okay, let's say it's at 40.5 without attaching any load to it. Do you understand?
Yes, sir.
So you have to record that value as your initial length without any load being attached to your horizontal meter rule.
So,
So
why 45?
why 40.5?
Yes, sir.
Okay, now look at where the meter rule coincided with on the vertical meter. Yes, on the reading on the vertical meter rule. Where do you think the horizontal meter rule is exactly on? What value can you take if you are asked to?
So I'm seeing 40.2.
Yes, that's why I said, believe me, I have taken the precise value. This is a record. You may not know the precise value from there. Had it been you are close to it, maybe you have taken 40, you may have taken 40.5. And maybe the value that I've taken is 40.2, exactly what you are saying. Do you understand?
Yes, sir.
Yes. So now I said we can take any value and assume. Because from what you said, me too, I can see 40.2. So 40.2 might be the precise value and might be the value that I've taken, right? So now let's take 40.2, since we can see 40.2, right?
Yes, sir.
So we can say yes, the meter rule was
Yes, sir.
initially at 40.2 before attaching any load to it. Do you understand? This is when we are measuring for length of 90 centimeter. For example, let's say we are done with 95 and we have taken the same procedure. Do you understand?
Yes, sir. Thank you,
So
sir.
yes, the next thing to do is to attach our load, and then we allow it to swing for 20 oscillation with that load attached to it. So after adding load to it and allowing it to swing for 20 oscillation, do you think the meter rule is going back when you, after you allow it to swing for 20 oscillation, then you remove the load, and then you look at it and see if it goes back to that exactly 40.2? Do you think this will happen? It's possible.
Yes, sir. It's possible depending on the force.
The quality of the meter rule, not force, right? It depends on the quality or strength of the meter rule or the young modulus of the meter rule, right?
Yes, sir.
So now we allow it to swing for 20 oscillation and then we remove the load and see if it goes back to that initial length. Do you understand? So now we're going to allow it to swing so that you see how much work is being added or put on the, is being added or is being done on the meter rule, which is going to induce some depression to it, definitely, depending on the quality of the meter. So this is what I'm talking about. After 20 oscillation, we've taken the value for the time T1. We do the same thing again to take the value for time T2. So how do we get our depression under that second serial number? So that's where we are. That's where we are now. So the next thing to do is to what? Take it back to that. You remove the load and allow it to see if it goes back. Remember, before taking your initial value, you didn't touch your horizontal meter rule. It was exactly at a particular length on the vertical meter rule, and that was your initial value, which we have taken to be 40.2, right?
Yes, sir.
So after allowing it to swing for 20 oscillation with a load of 150 gram attached to it, then you allow it to see, you remove the load and see if it goes back to that 40.2. So if it goes back to that 40.2, your depression is going to be 40.2 minus 40.2, which is what? 0 centimeter. Do you understand? But what if it goes back to 40.5? Remember, oh sorry, when it goes back to, it can never go back to 40.5. But what if it goes back to 40.8? Then you have to subtract your initial value from what? The final value, which is 40.8. Remember, if it goes back to
It will
40.8, it means it has what? Lose some elasticity. Or it's saying that your meter rule is not 100% elastic anymore because it has reduced its elasticity. It has bent downward. It has attained some permanent bending. Do you understand? Let me write something so that you understand better. Let me write. So what I was trying to say is, can you view what is on the board?
So I can't see it.
Oh, you can't see? Okay, sorry. Okay, do you see what I just draw?
Yes, sir.
Yes, sir. Okay.
Yes, sir.
So this is, for example, your meter rule, how it's going to bend. Remember, even without attaching any load to it, your meter rule will definitely bend because it has what? A certain length and it's elastic body. So if you hold one end of a meter rule, it's not going to be straight, right? The other end is going to bend a bit depending on the size of the meter rule. Remember, if you can take maybe a 50 centimeter meter rule and hold it horizontally like this, it may not bend that much because the length is not that big, it's smaller, right? But if you take a 100 centimeter meter rule, you have seen on the in the video that if you hold one end of a meter rule that has a length of exactly 100 centimeter, definitely you're going to have some certain depression in the other end. So this is how it's going to look. It's going to depress at one end. This is how cantilever is. When you're holding one end, the other end is going to depress a bit, even without attaching any load to it. So now, if let's say this is how your meter rule looks like before attaching any load to it, then after attaching load to it, it might depress maybe to 2 centimeter. If it was at 4 centimeter before attaching anything to it, sorry, 3 point maybe, we can say 3.8. if it is at 3.8 centimeter before attaching anything to it, then after attaching a load to it, it may go down. It may go down to, let's say, 2 centimeter. Do you understand?
Yes, sir.
Yes, sir.
So what I'm saying is, after removing that load, what do you think will happen to the meter roll if I remove the load?
To descend.
Eh? You have a load attached to it, and that load, you're going to allow it to swing for 20 oscillation on the meter roll. So after removing the load, my question is it going backward? Or will you,
Yes, sir. It's going back
it will go backward, but you are not
to its
very sure if
normal.
you are not very sure if it's going to go back to that 3.8. Maybe after
Yes, sir.
removing the load, it will go back to this position. Maybe after removing the load, it will go back to this position. Do you understand?
Yes, sir.
So maybe after removing the load, because it has what? Permanently bent downward due to the load you attach to it. It's not everything that has 100% elasticity. For example, even if you are given a spring and you decide to extend it to a remember, every elastic body have a plastic stage. Limit, yes. So now what I'm saying,
Breaking point.
yes, breaking point also. There is a breaking point. If you extend this meter rule to a certain length, it might what? Break completely, right?
Yes, sir.
So now it hasn't, yes, nothing has broken. But you have attached a load and allow it to swing for 20 oscillation, and then you remove the load. So after removing it, it may go back to a length, which is what? A bit lower than its initial length before attaching the load. So what I'm saying is your depression is going to be the initial length minus your final length. So remember, initial length was 3.8. If this is how it is, if this is our meter rule, remember between each of the lines I have there is 5 calibration, which makes each calibration to stand for 0.2 centimeter, right? Do you understand?
Yes, sir.
So therefore, if this position is 3.8 and this is 3.2, then your depression centimeter under the serial number and length of 90 here, then we're going to have a depression of 38 minus 3.8 minus 3.2, which is going to be 0.6. Do you now understand how we got the S?
Yes, sir.
All right, good.
Yes, sir.
Okay, let me go back to the table. Okay, Nafisa Liman.
Yes, sir.
Nafisa Liman, under serial number 3.
Yes, sir.
Serial number 3.
Yes.
What do we have as our length?
85
Serial
centimeters.
number 3, 85. So how do we get the time T1? You can see the value on the board, but how do we get it? Aisha Saad,
Shall I come again, please?
I said under serial number 3. Under serial
Yes, sir.
number 3, what do we have as the length? What do we have as our length? 85. So how do we get the time
Yes, sir.
T1?
85. We oscillated the meter rule for
Okay,
85
we are,
seconds.
but what do we do first? Remember, I said under length 85. So how do we get that length 85? Didn't we make any adjustment on our horizontal and vertical meter rule? Okay, how do we adjust
Yes,
it?
sir.
Which one did we adjust? The standing or the horizontal? The horizontal,
The
yes.
horizontal.
Good. So we adjust it to what? The length of 85, which was initially on 95, and then
Yes.
we made adjustment to 90 and then now to 85, right?
90 and 85.
So after adjusting it to 85, what did we do next?
Yes, sir.
What did we do? Abdul Salam Aminu?
Yes, sir.
Yes, after adjusting it to length of 85, what did we do? How did we get our time T1?
After we adjust it to 85 centimeter, we calculate the S first. We got our reading for S before we
Depression S?
add the depression of S.
No, why are you skipping to depression? My question is, how do we get time T1?
Yes, sir.
Yes.
Before we add the load and calculate it for 20 oscillation.
Yes. Actually, we went ahead and what? Swing it, right?
Yes, sir.
Length of what? 85.
85.
Right? Yes.
Yes, sir.
But how do we make the swing? Remember, we'll have to what? Notice the length before attaching our load, right? We'll have to notice the position of our horizontal meter rule on the vertical meter rule, right? So after noticing the position, then we'll take it back to that position and release it. Then we allow it to swing for 20 oscillation, right?
Yes, sir.
Exactly after 20 oscillation, we're going to take the value for what? Our time T1,
reading.
right?
Yes,
that
sir.
reading is our time T1, right? Are you with me?
Yes, sir, I'm with you, sir.
Then we'll do the same thing again and take another reading,
time
T2, right?
Yes, sir.
Yes. Good. Alex.
Yes, sir.
Are you with us?
Yes, sir.
Okay, good.
Yes,
if
sir.
you really understood what I just said, how do we get our depression on serial number 6? How do we get the reading for S on serial number 6, which has the length of what? I would like you to explain in brief.
Sir, I didn't fully understand the depression, and my network is always breaking when you're
Make sure you
speaking.
watch the video so you understand it better. But I'm going to ask somebody to explain it. Asikaru, are you with us? Asikaru, Elizabeth. Yes, please, can you explain how we got the depression under serial number 6? If you look at it, the value is 0, 0. So why is it 0, 0?
You subtracted the value you got from like 40.5.
Okay, can you start by telling us how we got the length of 70? And then you can skip to depression. I want you to explain it in brief. Remember, you're going to add this explanation to your discussion before submitting your manual. So you need to know what to do.
The Mac 70 was like is where you put the G clamp.
Yes, good. Yes. You make sure that it's on what? 70, right?
Yes.
And the displaced path is going to be from 70 down to 0, right?
Yes.
Okay. So how do we get, why is it 0.00? Why do we have 0.00 as our depression?
Because you subtracted 40.5 from...
No, it's not 40.5. Remember that 40.5, it was an example for serial number 2. Remember, by adjusting your horizontal meter rule, your initial length also will change. It's not going to be constant. The initial length for 95 is different from that of 90, different from that of 85, also different from 80, 75, and 65. So all of them are going to have, they all have different initial length. Because by adjusting it, it's going to either move up a bit or down. So for each length, you're going to record your initial length for each length. So if let's say at that 70, our initial length become 20.5. Are you with me?
Yes, sir.
Yes, if let's say it becomes 20.5 and then we attach our load to it and then allow it to swing for 20 oscillation. Then after 20 oscillation, are you with us? After 20 oscillation, hello?
Yes, sir.
Yes, sir.
Yes, then after 20 oscillation, we remove the load and allow it to go back. The meter rule to go back to a new initial, or we can say the final point or length. So let's say after removing the load, it goes back to 20. Remember, initially it was at 20.5. But now after swinging it for 20 oscillation, it goes back to 20. So how are we going to get our depression from that value? Elizabeth?
You subtracted the 20.5 from 20.
And then we're going to have what? Yeah? Then it would have been what? 0.5. 5. So what if the initial length is 20.5? Yes. But we were still having 0 as our depression. Why do you think is that? What does it say? If the depression is still 0 and our initial was 20.5.
So I don't know why it's still 0.
Okay, I understand. You may not. Nana boy.
Yes, sir.
My question here is, we have our depression at 0.00.
It's because when you subtract the final height from initial height,
Mm-hmm.
since the ruler went back to the original height that you measured initially, then the depression would be 0.
Okay, if let's say after allowing it to swing for 20 oscillation, then the meter rule goes back to that exactly 20.5, right?
Yes.
Yes. So therefore, our depression will be 0 because 20.5 minus 20.5 will give us what? 0, right?
Yes, sir.
Yes, good, good. So I hope you understood this. And then let's go back to our manual. If you look at it, we have 2 more columns to fill up. We have 2 more columns, so we don't know what to put there. Then we can go back to our manual to see what we're supposed to have in these 2 columns. And I'm going to ask question on it. Farha Gezawa. Farha Gezawa.
Yes, sir.
All right. Can you read the first question?
By plotting a graph of T2 against L3, determine the Young's modulus of the meter rule.
Okay, we're plotting graph of what?
Of T2 against L3.
Okay, this is T squared. So what do you understand by T?
So, the T.
Yes. Remember, we have T1 and T2, right?
Yes.
We have a column for T1 and T2. So if you look at the question, we're supposed to create 2 more columns for what? T squared and L cubed. And the unit for T squared is going to be second squared. And that of L cube is going to be centimeter cube, which is another unit for what? Volume, right? So that means we have 2 more columns to create, that of T squared and L cube. But we already have T on our table and we also have L. So all we have to do is to take the computation and then make our substitutions, right?
Yes, sir.
Do you know what T squared stands for? Okay.
Come again, sir.
Okay, yes. So we're going to create 2 more columns to our table. That's what I said. And that column are going to be T squared and L cube, according to our question. Remember, we're plotting graph against of T squared against L cube. So if you're plotting graph of 2 more parameters, then you have to add those parameters to your table, which are T squared and L cube. Do you understand? So for T squared, T stands for period on our table. If you can remember, how do we get period? We'll go back to the table and somebody is going to explain that. So T is our period and L is our length. Do you understand?
Yes, sir.
Okay, yes. Favor. Chisholm. Clinton. Ahiru. Who is here?
Yes, sir.
Okay, Chisholm, can you read the second paragraph?
Yes, sir.
Second paragraph. Yes, sir.
By studying carefully the given theory, suggest other methods that can be used to determine the Young's modulus of this material.
Okay, so you see this is another question and it carries mark. So after studying, finding the first, after solving for the first question, then you have to solve for the second also. So now we have to create a new columns, 2 columns to our table. So let's go back to our table. Okay, good. So, Drusilla, David Seriki.
Sir?
David, yes.
Sir?
So we're going to create 2 more columns, right?
Yes, sir.
So as you can see on our table, we have 2 more space that we're supposed to fill out, right? So the first one is going to be t squared, and the unit is going to be second squared, right? And then followed by that, yes, followed by that column, we're going to have another column for L cube, which is going to have a unit of centimeter cube. Are you with me?
Yes, sir.
Good. So now the next thing to do is to what? Fill up our table. We already have everything that we needed. We have T1, we have T2. Then how are we going to get T average? The column for T average, how are we going to get it?
Sir, can I try?
Yes.
T1 plus T2 divided by 2.
Okay, so we're going to add T1 and T2 for each row, right? From each row, we're going to sum up T1 and T2 and then divide it by 2. Then we add the value to T average, right?
Yes, sir.
Yes, that's very good. That's what I was expecting. Then for T period, somebody was trying to say something.
You will divide your T average by 20.
Okay, well, after getting our T average, we divide it by 20, and that's how we're going to get what? The column for the period, right?
Yes, sir.
Hello, and what's the unit for that column? Period. What do we have as unit?
Sir, S.
S, yes. Second. Good. So now my question is, remember we're going to add 2 more columns, Baratu and Audrey. These are your questions. Andy Anga, are you with us?
Yes, sir.
Okay, Andy Anga, how do you think we're going to get our column for L cube? Remember, these are the 2 columns that we're going to add, T squared and L cube. So how are we going to get that of L cube?
You find the cube for each L.
Okay, cube for each L. Can you give us example?
95 cube.
Consider number 1. Then we take 95 to the power of 3, right?
3, yes, sir.
Whatever value we have, we add to L cube under that same row. Right?
Yes, sir.
Good. And Doe, are you with us? Doe?
Yes, sir.
Okay, so how are we going to get the value for T squared? Our new column, T squared. T squared. How are we going to get the values for T squared?
We take the values of t and square them
Yes,
individually.
that's very good. So this is all about how to fill up our table. But after filling up our table, we do have some other few things. Remember, as I've said, we're going to have analysis after each experiment. So for last 2 weeks experiment, for our first experiment, I've already sent the analysis to you. But for this experiment, we're going to have a live analysis together with you, and it's going to be by next week. Remember, after next week, you're not going to have, after the analysis, you will be given maybe 5 or less than 5 days to compile your report and submit it. As you see, your first and second experiment is going to be your continuous assessment, the report for first and second experiment. But before then, we're going to have analysis on this experiment live. I'm not going to send a video record, but we're going to have a live analysis together. So if you have any question, you can ask. Anybody, you have any question?
But it's regarding to the former experiments, the last experiment.
Okay, what was your question?
So when plotting the graph, sir.
Yes.
The graph is a little bit complicated, sir, because I'm having different values of minus.
I don't understand. Different values of minus, like how?
Yes, sir. In my t square h axis.
Yes.
My
You are having minus. How do you arrive at minus?
Sir, because in the reading, we have our h to be -5.
Yes, if h is -5.
Yes, sir.
Are you with us?
Yes, sir.
Then what is your period?
My period is now 1.45.
Okay, so if you multiply it with your h, you will arrive at what, negative value, right?
Yes, minus 10.6.
That means in your graph, remember graph, you can either have positive or negative. So
Yes,
it's
sir.
possible. That means you're going to what? Make provision for the negative graph. You make provision for negative graph. Remember, your y-axis, you're supposed to have positive y and negative y. Your x also, you're supposed to have negative and positive. Then you have to make a cross graph table. Cross graph. You make cross graph, and then you create. You have to find a suitable scale that will suit your values for both negative and the negative and the positive. Do you understand?
Yes, sir. So that means in the scale is going to be one scale, or it's going to be different for the positive and for the negative.
It must be the same. Remember, if let's say, let me give you an example. For example, you have a value of -1, -2, and you also have a value of +1 and +2.
+2.
Yes. So if you are choosing a scale for both, you can say yes. One, if you are taking just a 1 centimeter to represent your, let's say, one either second or anything, then you can look at the space between them. Between 1 and 2 is same interval between 1 and 0, and also between 0 and -1 is same interval between the interval you have between 0 and -1 is same interval as between 0 and 1. Is that not?
Yes, sir, it is.
So I don't think it's going to be a problem because it's same interval. So you must take the same scale all through. You can't take a different scale, your negative axis, and then different scale for positive. It must be the same.
Okay, sir.
So if you are having a larger value, you can give us examples so we can help you out. Remember, if let's say the values you are having is in thousands, then you can make it in standard form. Remember, 10,000 is equivalent to 10 times what? 10 to the power of 1. Sorry, yes, is it 10 to the power of 1? No, 10 times
10 to the power of 10.
Is 10 to the power of 10. So you can make it 10 to the power of 10, and then you look for scale of 10, right?
Yes.
Yes, you look for scale in space of maybe 10 to 0. So it's
Okay,
as
sir.
easy
Thank
as
you.
that. But your scale must be the same. You can't take different scale. You can't arrive at the accurate value or accurate answer. So any other
Okay, sir.
question? Hello, any other question?
Yes, sir. Regarding this one again, sir.
Yes.
This our S, is it
Our
going to show in our this S in our table?
definitely is going to be, look at the table, the way I gave you, that's how it's going to appear in your manual. In your report, you must make it the same way as this. If you like, you can make your S to be your second column or third column or fourth column. Anyhow you decide to arrange your own table is fine with me. But you have to make sure that your table have all these columns. How many
I
columns
mean,
do we have? Beside the serial number, we have the length column, the time T1 column, time T2 column, T average, period, S, which is depression,
H column.
T squared, and LQ column. So you're going to have all those columns that I've made mention. But I don't care
Yes.
how you design it. You
Yes,
can,
I'm not talking about the column. I'm talking about in graph.
yes, in the graph. No, the S
Yes.
is not going to be there. Look at the graph that you're going to plot. It says T squared against L cubed. You don't need S in it. Your S will only remain in your table. You're not taking it anywhere. But I don't know, maybe in your calculation, you're going to need it. Remember, there is an equation that will support your graph. And that
Graph. Yes,
equation
sir.
is going to be under our analysis. We're going to discuss on how to go about the equations by next week.
Okay, sir.
All right. Any other question?
Thank you, sir.
Any other question?
Excuse me, sir. No, sir.
Okay.
No, sir.
Sir,
Sir.
how did you... Sir, I
Okay.
have a question.
Okay, one person at a time.
Sir, how
Fatima
did you get...
Diko, then Raymond. Fatima, are you the one?
Sir, please... Yes, sir.
Okay, what was your question?
Sir, please, how did you get the S in the table?
The S?
Yes, sir.
Okay, it was from our experiment. Remember, do you know how we carry out the experiment for serial number 1, which is 95 centimeter?
Yes, sir.
We have to make sure that we attach our horizontal meter rule at what? 95. Then we'll allow 95 down to 0 to swing, right?
Yes, sir.
Okay. So before allowing it to swing, we'll have to record the length that coincide with our vertical meter rule, right?
Yes, sir.
So if that length was 20 centimeter, then we're going to attach load to it and then allow it to swing for 20 oscillation. Then we record our time T1, right? So after doing so,
Yes, sir.
we're going to remove our load. Then we'll remove our load and then we check whether the meter rule will go back to that initial length, which was maybe 20 centimeter, right? Hello?
Yes, sir.
So if it goes back to that 20 centimeter, then it means we don't have any depression. But if let's say it goes back to 20.1 or yes, it goes back to 20.1, then we'll have to subtract 20.1 from our initial length, which was 20. And that would be our depression. Depression is only measuring how elastic our meter rule will remain after attaching a certain load to it and allowing it to swing. Remember, that load that we're attaching to it is to stress our meter rule, to stress it to see if it's going to maintain that stress without losing its elasticity. Do you understand? So if it goes back to that initial length, that means it hasn't been stressed because the elasticity is the elasticity is still 100%. But if it goes back to a length other than the initial length, then we'll have to subtract the initial length from it. to see how much depression we have. Do you understand?
Yes, sir.
Are
Yes,
you
sir.
are you sure you're with us? Please watch the video again. If you still have problem, then you can contact me.
Yes, sir.
Okay.
In case if we are to take the experiment ourselves,
Yes.
for the depression, are we going to count it after the first reading, or we are going to count it after the second reading?
No, you are taking it twice for time T1 and
Yes,
T2,
sir.
right?
Yes,
So
sir.
you're going to take it after the second.
Okay, sir. Thank you, sir.
Yes, very good question. Raymond, you wanted to ask something. Ask question.
Yes, sir.
And what was your
So
question?
when you are taking the readings for S, after you have done the first length of 95,
Yes.
is it the same original length of 95 you use, or when you put
No.
it at 90, you then take a new original length?
No, you take original length for each length. When it's
Okay,
at
sir.
95, it's a different original length. At 90 also is different because as you are adjusting the length of the horizontal meter rule, the height is also reducing. Oh, sorry, the height is also increasing. Remember, if at 95, the meter rule will bend, at 90, you shouldn't expect it to bend downward as 95. It's going to go up a bit. Remember, as I've said, the more the length of the meter rule, the more depression you're going to have. The lesser the what? The length of the meter rule displaced, the lesser what? The depression you're going to have. Do you understand?
Yes, sir.
So, and also if you look at the reading, even though we're having some random depression here on the result, but this is experiment, you have to record what you observe. But if you look at it carefully, you see that we only acquired zero depression at what? Our sixth reading, which is almost what? The reading close to what? Our last reading. So that's how it's going to be. The lesser the depression, the lesser the length, the lesser what? The depression. The initial length will also what? Increase. So therefore your initial length will change for each length. Are you okay?
Okay, sir. Yes, sir. Thank you, sir.
All right. Any other question?
Yes, sir. How did we get the T square?
T squared. Do you know
Yes,
how we
sir.
got the period?
A little, sir.
Do you know how we got the capital T, which is period?
No, sir.
Okay. But you know how we got T average?
Yes, sir.
So look at the bracket on the T, the period column T. You see that we have T average over 20 oscillation, right?
Yes, sir.
That bracket. So that's what you're going to do. You're going to take that T average and divide it by 20 oscillation. Whatever you have will be your capital T. And then T squared is going to be the square of that T that you initially have.
Okay, sir. Thank you, sir.
Good. Any other question? All right, good. So we're going to stop here. By next week, we're going to take our analysis on experiment 2. And then I
So
will
I
give
have a
two.
question. So I please have a question. Please, how do you get the T average?
T average. Okay, if you look at the table, we have two small letter T's, right? The T1 and the T2, right? Hello?
Yes, sir, I see it.
Okay, so if you are given two numbers and you are asked to calculate the average of two numbers, what do? It's more like what? Finding the mean, if you can remember your statistics. If I give you three numbers and I ask you to find the average, you're going to add the three numbers and add them by what? 3. If I give you 5 numbers and I ask you to calculate the average, you have to sum up the 3 numbers. If it is 4 numbers, you sum up the 4 numbers and divide it by 4. If it is 5 numbers, you sum up the 5 numbers and divide by what? 5. So here we're having what? 2 small letter T's, the T1 and the T2, right?
Yes,
So
sir.
we're going to take the summation and divide by what?
2.
2, because the numbers are 2, right?
Yes, sir. Thank you,
Good.
sir.
This is how you're going to get the average. Okay, any other question? Sadia Salim Jibrin. Sarah. Tabira. Valerie.
So,
Valerine, are you all with us? Yasmin, you're not saying anything.
Yeah, I had
Zainab,
network.
all of you, are you with us?
yes, sir.
Good.
Yes, sir.
Any
Yes, sir.
question? Halima, any question? Zainab Tahir, are you sure you're okay? Ellie,
Yes, sir.
are we okay?
Yes, sir.
All right, we're going to stop here. No attendance. I'm going to use your recording to sign your attendance. I'm going to use the video recording to sign the attendance. So we don't have to do it now in live. All right.
Thank you, sir. Thank you, sir.
All right. Have a
Thank
good
you,
day.
sir.
Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you,
Thank
sir.
you, sir.
Have a good day. Thank you.
Sir, I
All
wasn't
right.
around like half of half of
Yes,
the class.
me?
Yes, I wasn't
Yeah, you have a question?
half of the class.
Oh, you're just coming?
No, I came earlier, then I had network problems, so I wasn't able to be part then.
All
Now
right.
it got
All right.
better, so in case you don't see it in your
All right.
record.
I'm going to post the video immediately in next maybe 20 or, yes, 20 minutes. You're going to receive the video. So please try and download it and watch it. If you still have a
Okay, so
question,
that's the same thing I'm going to do.
then yes, download it and watch it. If you still have a question, then you can contact me. Send it to the group, or yes, you can contact me via
Okay, sir.
the classroom.
So
Sir,
about the group,
Okay.
I'm not in
Yes.
the group. Can I be joined or number or something?
Oh, you are not part of our classroom. Classroom?
No,
You are not?
no, I'm not. Not this class.
So how do we get this? How do you get here?
You said, oh, don't worry, it's okay. Sorry, sir. I was
The
confused.
classroom. What I'm saying is, are you part of our classroom?
Yes, I am.
All right.
Sorry, I
So
was
I'm going to
confused.
send the video. So
Okay.
try and download it and watch the video at your leisure. Watch it. If you still have a question, then you can send it to me.
sir, the assignment about the readings, how do we submit it?
The readings, yes, it's going to be, you're going to type it. You solve it, you need to start working on it now. After you're done, then you'll type it. For the graph, you can scan it and then attach it to your file.
Okay.
You know how to scan. If
And then
your phone
apart
is
from the
very good, you can scan your file.
other experiment we have to do,
No, you're just doing 2 as your assessment for now.
that's with
Then after you're done with the assessment, we're going to complete the remaining ones.
yes, that's the young modulus and the other one.
Yes.
Yeah, that's what I'm asking, sir. Which other one apart from the Young's modulus?
The first experiment, which is the determination of acceleration due to gravity by means of compound pendulum.
Okay.
Sir, will you send the readings in a form where we can submit it?
You already have the reading in your notes. Remember, you are creating a document, and all these readings are going to be inside your document. So all you have to do is to take the video, record the video. Everything is inside the video. You take the readings and then type. Remember, you're typing. If
Yes,
you
sir.
have the video, you have everything, right?
Yes, sir.
All right, good.
Excuse me.
So you video, please.
Sir, this is my first class.
Okay. Abdulrazak,
Yes.
you're the first person that showed up, and I think my network was bad, and I couldn't hear you. You were saying something then. So please try and watch all the videos. If you still have a problem, then you can contact me.
must I type it? Can't I just write it on a paper and then scan and send it?
Because we're going to enroll it to Turnitin to make sure that you didn't plagiarize anything. We have to make sure that your work is original, and Turnitin cannot see your handwriting. It can only see a typed version of your work.
So we're only going to
When are we
solve
submitting?
and
Turnitin.
No, like when are we submitting it?
That's why I said after our analysis, you have to start working toward submission, because after our analysis, which is going to be by next week, all I'm going to do is to give you 3 or 2 days to compile your work and submit. So what I'm saying is you're not
Okay.
going to have enough time to do your work if you have not started now.
Oh, okay. Okay, thank you.
So make sure you have started it, because we are done with both experiment one and the analysis for experiment one. So all you have to do is to compile experiment one. So for experiment two, you can wait till after the analysis if you want to, but you can still start something that you can do. Start doing things that you can do.
now for this experiment, we're just meant to complete the table and plot the graph, right?
You have your manual, and everything is in the manual. All the provisions, all the things that you're supposed to do, we have created a space in your manual that you're supposed to fill up. So you're going to fill up, you're going to compile your report according to the provision that was given in your manual.
So each time I try to download the manual, it's not organized well enough for me to add my write up on it.
The manual is in PDF, right?
Yes, but each time I try to download it to add my own write up for the experiment, it wouldn't work for me properly. So I decided to do it separately. So would you accept it like that, or do I have to?
No, once you follow the format of the manual, I will accept it. All I'm asking is for you to follow the format of the manual.
Okay.
So you don't have to convert the manual to Word and then start filling the manual up. You can create your own manual, but make sure you follow the format of our manual.
Okay.
Right.
Thank you.
You're welcome. Who's
sir.
saying it, sir? You have a question? Please, we are done. So if you don't have any question, you can go offline. Have a good day.
Sir.
You have a question?
No,
Okay. Who else?
It's
I
me
have a
still.
question about the graph.
Okay, Abdulrazak first. Abdulrazak,
Yes,
what
sir.
was your question?
Okay, so it was on the table that you just drew. At 70, the depression was
Yes.
hello?
Was what?
It was
Yes, I can
0.
hear you.
Yes, the
Yes.
depression. So can you say that it was elastic at 70 or?
Yes, it's definitely elastic at 70. That's what it means. It hasn't changed between 75 and 70. That's what it means.
Okay.
Do you
That's
understand?
awesome. Thank you.
Yes, good.
Okay.
Somebody
Sir,
is trying
excuse me.
to say yes, we're saying sir.
Sir, I really don't know how I'm going to plot the graph.
That's why I said I'm giving you option. You can either use paper and pencil to plot it and then scan it to attach to your work, or you can use Excel, Microsoft Excel. Anyone.
Okay, sir. Thank you.
All right. You're welcome. So have a good day. Innocent. Innocent. Who is Innocent Ugbo? Innocent. Is he around? Anybody that knows Innocent here? Stephanie.
Yes, sir.
You know Innocent?
I know the name.
Innocent.
I don't know the personally.
Innocent Ugbo. Somebody innocent. Okay. All right, no problem. I'm going to email because our
So
video
I
is
want
going
to
to
confirm
stream.
something.
You said?
I want to confirm something again. For approximation, it's okay to use significant figures or decimal places.
You said?
For approximation, it's okay to use either significant figures or decimal
Yes,
places.
I said you can use 2, you can use 3, anyone, but make sure that you are If you have chosen 3, you have to maintain that 3. I don't want a situation whereby you start with 2, you now extend to 3, and then later you change to 2 on the same table. It's going to look rough, and you're not going to have the full marks.
Okay, thank you, sir.
All right, yo. Hello, nobody knows Innocent Ugbo? Nobody. All right, have a good day.